Hello everyone, my name is Yash Anand and today I will present two research papers that form the backbone of our DSC 672 Capstone project. These papers are highly relevant to our goal of building a conversational cross-medium recommendation system that works across movies, books and games. Let's start with the motivation. Our projects attempt to solve two major challenges. First, recommending entertainment across different domains, like movies, books, and games, which are semantically and structurally very different. Second, enabling this recommendation process to happen through a natural conversation with the user. The two papers I selected address both of these. The first one introduces a deep learning method for cross-domain recommendations. The second focuses on building a conversational recommendation system. Together, they provide an algorithmic and interactional framework for our system. The first paper is titled Cross-Domain Recommendation via Deep Domain Adaptation, published in ACM TOIS by Zhang and colleagues in 2018. It focuses on how we can transfer knowledge between different content domains, such as using movie preferences to recommend books. A major limitation of most recommendation systems is that they only work well within a single domain, say recommending a new movies based on previously watched ones. But if we want to recommend books to someone based upon their movie preferences, that is where cross-domain recommendation comes in. The challenge here is that the items and the user preferences differ vastly across different domains and are often not shared identities. This paper tackles the exact challenge. The authors proposed a technique called deep domain adaptation. The idea is to map both source domain data, like movies, and target domain data, like books, into a shared feature space using deep learning. This enables the model to infer connection between unrelated items across domains. The core innovation is how they jointly learn a representation that captures both individual characteristics of the items and underlying shared preferences. Now, here is a simplified architecture of their model. It includes separate encoder for the source and the target domain, a shared latent space in the middle, and a joint loss function to ensure both the domains align meaningfully. This design helped the model generalize across all domains. Their experiments on Amazon products datasets like books, movies, and movies show strong improvement over traditional collaborative filter models. Notably, their method works even when there is no overlap in user or items between domains. This is crucial in our case, where games, movies, and books have entirely different metadata and user interactions. This paper is extremely relevant because our project faces the same problem. Combining reviews from three different datasets, Movie Lens, Good Books 10K, and the Steam dataset, we can use these domain adaptation frameworks to map all these content types into a shared latent space, which will make it easier to generate meaningful recommendations for our system. The second paper is Conversational Recommendation System by Sun and Zhang, represented at SIGIR 2018. While the first paper focused on algorithmic modeling, this one focused on user interaction and how to recommend through a dialogue instead of a static input. Now, typical recommendation systems expect users to fill out a profile or rate several items before they can make a recommendation. But that's not natural for users. People often prefer to give feedback through a conversation. This paper aims to build a system that interacts with the user like a real dialogue, asking for a feedback step by step and refining its recommendations along the way. The author proposed a system with two main parts: a dialogue manager, which uses reinforcement learning to decide what to ask, a recommendation engine which uses gathered responses to make a better suggestion. The idea is to adapt and learn what to ask and when to ask, minimize the user effort, and maximize the recommendation accuracy for the model. Now, here is an example of what such a conversation might look like. System: do you prefer action or drama? The user: drama. Do you enjoy classic or modern films? This dynamic process personalizes the interaction and captures nuances, preferences much better than a static form could be. Now, they evaluated their system using real user sessions and found that it leads to a higher satisfaction and better click-through rates compared to a traditional recommendation system. One key insight is that the user appreciated being guided through a conversation. It felt more human and less like filling out a survey. This aligns perfectly with our use of Chainlet and ChatGPT 4.0. We are building a system that asks questions conversationally, gather user preference in real time, and tailor recommendations accordingly. This paper validates that approach and offers ideas to improve the user dialogues. Now, to summarize, Paper 1 gives us the technical foundation for cross-domain modeling. Paper 2 provides an interaction model for dynamic and conversational preferences. Both the paper addresses the exact system challenge, aligning multiple content types and doing so via natural conversation. These works not only guide our current implementation but also point towards future enhancements like shared embedding and smarter dialogue strategies. By combining the strength of both the models, our system becomes more robust and scalable and more user-friendly. Now, here are the full reference for the paper I present. Thank you for listening. Have a nice one.